Look at these static-filled screens. They represent a comforting assumption we make from birth. When you turn off the lights and close your eyes, you assume the desk, the walls, and the entire city outside your window are physically sitting exactly where you left them, solid, permanent assets. We build our own digital worlds using a more efficient logic. In modern video games, rendering an entire city all at once would be a waste of resources. Instead, developers use Frustum and Occlusion Culling. The engine only generates pixels in your field of view. The moment you turn around, the world behind you is instantly deleted from active memory. This is a mathematical necessity. If a computer tried to render every blade of grass and every shadow across a map simultaneously, memory usage would spike and the system would crash. The engine must call the unseen data to maintain stability. Our physical universe appears to operate on these exact resource-saving protocols. The deepest laws of physics suggest the cosmos is running its own culling engine. If the universe utilizes this logic, it means the space directly behind you only populates the moment you turn to look at it. It's a staggering proposition that suggests our world is far less permanent than we assume, technically non-existent until verified by an observer. We found the first evidence of this mechanism in 1977. Two physicists, Baidyanath Misra and George Sudarshan, were running quantum observations and stumbled upon a phenomenon that functions like a bug in the universe's source code. In standard physics, an unstable radioactive atom follows a strict, predictable rule. It decays and breaks apart after a specific amount of time. Under normal conditions, that countdown is inevitable. But when Misra and Sudarshan placed these particles under extreme resolution digital lenses and checked them continuously, they observed a glitch. Without a single millisecond of pause in observation, the particle completely stopped decaying. The mere act of measurement, of watching the atom, forces the internal decay clock back to zero every time. By checking the particle, the physicists trapped it in a time loop, physically preventing it from changing state. This is the Quantum Zeno Effect, a physical freeze induced by the presence of an observer. A subatomic particle isn't self-aware, it doesn't know it's being watched. The freeze occurs because the observer's data request forces the master system to hold that specific asset in its active memory. This is identical to an active layer in software engineering. When a user interacts with an asset, the computer halts background changes to prioritize rendering the data currently being examined. Within a simulation framework, this freeze suggests a processing bottleneck. A system flooded with observation data might lack the overhead to execute background tasks like atomic decay, essentially locking the asset in its current state. To prevent a local crash, the universe defaults to safety. It freezes the particle asset because the logic for your high-resolution observation and the decay physics cannot be processed simultaneously. Standard science curricula bypass this limitation. Textbooks describe the universe as an infinite machine, ignoring the blatant resource-saving bottlenecks occurring at the quantum level. Mainstream science functions as an algorithm of its own. It keeps your attention focused on neatly packaged, centuries-old theories, so you never poke at the rendering glitches right in front of you. The Quantum Zeno Effect reveals a hard computing limitation of the universe's hardware, a failure to execute background rules under extreme micro-level scrutiny. Take that exact same computing limitation and scale it from a single atom to the entire macrostructure of the galaxy. Look at the imposing structure of this telescope. If the universe follows culling logic, these distant galaxies are only rendered in high resolution because our lenses are forcing the server to load the data. This vibrant galaxy image hints at the macro collapse. If every human eye and every mechanical sensor simultaneously blinked out for 1 single second, the entire cosmic background would instantly unload to save memory. By accessing this data logic, you have altered your own parameters. The system is aware of your suspicion, and your rendering profile is being monitored right now. Our reality functions as a highly localized, temporary render, supported by a system working overtime to hide the void directly behind you.